Good morning. Thank you for joining us and welcome to our weekly e-learning session. My name is Dwayne Henderson, a member of Cree Lighting's training and education team and host of our e-learning series. For those watching live, happy Friday. Quickly about the session, once we begin, we'll have roughly 15 minutes of content. Our presenter will be available for Q&A at the end of the presentation. And although the participants are muted, we do ask you guys to use the Q&A box and chat box to ask questions. Feel free to do that during the presentation. 2 weeks ago, we took an inside look at layout creation for the outdoor space. Today, we're going to take that discussion and move it indoors. And to walk us through that, I'd like to welcome back Jim Blair. Good morning, Jim.
Good morning, Dwayne.
Hey, Jim, before we get started, can you quickly talk about your role in the business?
Absolutely. I lead the application engineering group with Frank Tempesta, and I've been with this great group for about 12 years.
Perfect. All right, well, let's get started.
Absolutely. Thanks, everybody. Good morning. We're going to revisit a previously talked about RP 1-12 as we look at the details of creating an indoor layout. I'd like to define the recommended practices for you before we begin this morning. They're a consensus-formed lighting recommendation from a knowledgeable and diverse group of lighting stakeholders that help guide the lighting design and product selection process. Notice the book in the lower right-hand corner here, the Lighting Handbook 10th edition. We're going to be referencing this in this training, and I'd like to talk a little bit more about this briefly. This handbook serves as a great open resource for all indoor areas that don't have specific RPs dedicated to them. You can find common lighting goals for corridors, common spaces, and many other applications as well. We can use this effectively as guidance on our design process. We'll see later how the RP uses this resource in conjunction with its own charts. If you remember back a few months ago, we covered the RP 1-12 standard practices for office lighting in greater detail. We're looking at this application today just with a little bit of a different focus, an angle, as we'll be creating a layout. It's much easier to get this process and mindset if you understand these interior spaces. So I do recommend that if you haven't done so, revisit this session if you haven't already. I've done my best to recap crucial items where they're necessary here. This should help us understand some key terms and strategies that guide the thought process that we're talking about today. So what's the plan today? We're going to highlight the differences that exist in an indoor project from our previous session on outdoor and offer a short checklist of items that will help you when you're submitting projects of this type. We'll also provide a refresher on some key definitions and introduce some new. I'd also like to pass on some tools for some quick wins. We're going to take a look as well at indoor evaluation process, that step before you submit project parameters. So last and not least, we'll show you the step in an abbreviated scenario so that we can show what it takes to create a layout from start to finish. This will be as familiar as last time, or similar to last time, I should say. Towards the close, I'll call out some important variables in the calculation summary that will need to be communicated to the customer. This will help us gain a better understanding of indoor. Let's look at a quick reminder on some of those definitions that we've covered previously. First is illuminance. This is the amount of light energy illuminated on a surface. Luminance is the amount of light energy produced by a surface. So basically light emitted from a fixture and then being calculated on a plane of calculation. But luminance would be that bouncing off. It would be the value coming from the ceiling. I'd like to introduce some new terms to you, so we're all on the same page when they're referred to in this training. A foot candle is the lighting measurement defined as illuminance on a 1 square foot surface from a uniform source of light 1 foot away. You can see this in the diagram on the right. The room estimator, this is a tool that we use within our AGI 32 software from lighting analysts. This helps us assemble luminaires into a rectangular array that achieves an average foot candle goal. We're going to be using this today as well. The work plane. This is really the activity level in the room and also where we place our plane of calculation. This is typically shown at 2.5 feet of finished floor, which in the office environment would represent a typical desktop height. And finally, the reflectances. These are the physical attributes of a surface in a room, mainly the color and texture. These all contribute to interreflections of the ceiling, floor, and walls that directly influence our illuminance calculations, sorry. Same as last time in our outdoor discussion, we have some familiar needs when it comes to the indoor layout. Back then, a scaled CAD file or a PDF of the site plan were the criteria that was critical, if you remember. But now we observe that there are a few additional needs that will help us assemble accurate and complete work on these indoor opportunities. Some new criteria would be existing ceiling types. These can vary greatly in a space, as you'll see in the example in the next slide. We need this piece of info. This will tell us which product we are able to recommend and install into that ceiling. If existing products are known and we're replacing that in the room, we need to know what it is and how it's mounted so that we do not recommend a product that doesn't offer that same value. The activity in the space and room names, this is a new one as well. And as unique spaces have different activities, their illumination needs are also different. The room name is critical in the space so that we can include multiple rooms that show up on the schedule that show line for line items, which we'll see in a little bit, the values that we're attaining in that particular area. Obstructions. There are many types and sizes of an obstruction in a building. We're more concerned with the larger ones, like racking in a warehouse or large equipment in a manufacturing plant. Basically, anything that potentially blocks out our light values. As the quantity of objects in the space increases, so does the calculation time that we need to pay attention to. So smaller objects may not be desired to create objects for. And then the description of the space, the colors of the ceiling, walls, and floor that we just talked about, these will all have an impact on the design values. If we're not offered this info, we do have some conservative values that we kind of fall back on. 75, 50, 20% reflectance values and the like. This might be a problem though if there are darker colors in the space or darker equipment that will absorb some of that light. Also, as a side note, I wanted to mention that we have gotten requests for indoor layouts of large warehouse spaces and that sort of thing with Bing and Google Maps for these indoor spaces. Please know that this is not possible as we have no way of knowing where walls are, where equipment is, and that sort of thing. Interior spaces can be extremely different with many combinations of variables, and the more data that we can obtain, the more sound the design will be. Let's take a look at the image here on the right as an example. The floor, the wall construction, and the ceilings have all different types and colors. This means that we'll need to assign different reflectance values for each part of that room. We can observe here that we have a glass wall partition that allows light to pass through and contribute to the corridor. If something like this is a known variable, we may be able to provide this information in the model for better accuracy. I also want to mention that the ceiling height and type change here as well. So we would need to know this prior to the design. If these aren't known, we'll fall back again on that solid wall standard reflectance of 50%. As I stated a few times, the more we know about the project prior to the design, the better. And inside a building, it can be a definite benefit to snapshot some of those photos if at all possible. They do say a picture is worth 1,000 words. This certainly is true and may offer some savings in time and energy. It's always best to ask though. We certainly don't want anybody to get in trouble, as some facilities have pretty strict camera policies. If you can't take the pictures, the detailed set of notes with a scaled plan will be very helpful. If you like a fancier approach and have a lot of money to spend, they do make indoor survey drones, but that definitely would need permission. This could be a handy tool if you were needing high bay information from a very tall ceiling height, or maybe there was some unmovable equipment that you couldn't get a lift into the space. So kind of a cool thing that I discovered. So picture this. You have $1 million interior opportunity for an office, and you just got a call and you're driving to meet the owner. Yep, we've heard that one before, and we know who you are, and we have your back. In the application reference on our spec sheets for the indoor product, you'll have exactly what you need to offer a good sound recommendation on your product and spacing. So we find on this chart that we have an 8-foot by 8-foot spacing using the ZR22 product with a 30L lumen package, and that will yield about 50 foot candles average in the space. We get to test this in a minute, so if you feel the need for speed, these tools can be a great conversation starter for you. There's another handy tool if you find yourself short on time and information. With some very general inputs, it is possible to get the ball rolling with a room estimator. The minimum criteria is length, width, and height in these areas, and we can still offer a total quantity in the space as guidance on a project. The output on the right that you see offers complete details to build out any space with the appropriate product. We can also incorporate that grid ceiling to see how everything spaces out. This is a great tool to leverage speed and comparison when more than one product is in the running. Keep this in mind, not every project needs to be a layout. We consider this to be a slam dunk. So we finally receive our background and layout request for an indoor office. We've evaluated the project for all of the following criteria in the list on the left here. And you find that you need to design this to RP1-12 values. One thing that you'll note is that the RP offers you 500 lux or 50 foot candles for a matte paper and ink surface for reading in this task area. And the average age of observer is assumed to be 25 to 65 years old. The RP then refers you to the Lighting Handbook 10th edition and Table 12.6 for the uniformity criteria. We'll often find that the recommended practices will refer back and forth to different articles and resources for different values. So they're very much tied together. To that end, we go in and we look in the handbook and we find that this interior criteria needs to have an average to min of 1.5 to 1 for this particular task area at desk height. Let's see how closely we can come in our design. During our evaluation of our CAD file, we noticed that there was an indoor grid in the ceiling of our space. That needs to be enabled. So we go into the project manager and we enable the grid in the space. This is an important step and reminds us that our spacing needs to be in multiples of 2. Our next step in the process is to add the room geometry. This can be as simple rectangle or a complex polygon shape like you can see in the green here on the right. This line is for illustration purposes only, and I'm purposely making it thicker than it would show up in AGI 32. But this is to show the perimeter of the room that's assigned a particular height of 9 feet in this case. Now it's time to load our fixtures in. On the left is our familiar tool in the room estimator. This allows us to see the spacing of luminaires prior to exporting the fixtures and room into the plan. We can't export it directly into the space, as this will add a room within a room, and on top of being the wrong shape, it won't calculate properly. But it does provide us with a reference point of a corner that helps us move fixtures only into our model and line them up on the grid. I've preset this for us, and I'm transitioning to the final product for time's sake. The room estimator is a great tool for a rectangle, but all we really need at this point is a guide for the spacing of product. We can continue this spacing around the geometry as needed. Our final step is to add the calculation plane into the model, and we use a work plane of 2.5 feet as mentioned above finished floor and hit full radiosity calculation. When we looked at exterior, if you remember, we calculated only direct illuminance. This is different indoors because we need to take advantage of all our interreflections that we mentioned around the room. So full radiosity calculation is a must for indoors. We have a choice here. We can use one plane of calculation throughout the entire space, or we can create individual rooms and assign them their own calculation plane. So with the first option, if we use the one plane, we can use a statistical area to create a zone within the calculation that will represent these individual spaces. You'll note that on the right-hand side, I have summaries that basically give me all of the information that would be populated in my calc summary. We've done this because most of the offices on the right-hand side here have glass walls, so a design choice was made to leave this open with no obstructions for the walls on the left-hand side. Our last and final step is to evaluate the results in our schedules. We observe that the room and the statistical area showcase the values on separate lines and are limited to only the calculation points that fall within those stat boundaries. This is an easy way that you can name and call out areas on a larger plan. So how do we measure up here against the RP1-12 criteria? In the overall space, we're at 50.43 foot candles and 2.32 average to min uniformity. Why is this? This is due to the complex shape of the space and the lack of symmetry in the layout towards the upper right. I've highlighted the low foot candle value that you see highlighted in red here. The typical office area, it would be my next focus because we're falling short a little bit at 44.22 average there. My next design step for that would be to move some fixtures around or increase the intensity of the luminaire. We can do this because we have great uniformity in the space to start with, and that will remain the same as the intensity goes up. We also note that the fixtures are pretty close to the walls, taking advantage of that interreflectivity. We could possibly move those a little bit together and raise the average, but we will impact the uniformity there. That's a design choice that we have to make at that point. So in closing, excuse me, as you've seen, the interior layout is quite a bit more involved and detailed than that of the exterior, and ample time should be allowed for completion of these plans. There are many tools if time is critical to win a project. Thanks again for your time. I'd like to hand off the presentation to Dwayne for any comments or questions.
All right, great. Thanks, Jim. Just to remind the audience that you can go ahead and submit those questions to either the chat or the Q&A box. And Jim, while we wait, just wanted to ask again about lumen loss or light loss factors or lumen maintenance or lumen depreciation, whatever you want to call it. You want to just talk a little bit about it in the indoor space as well?
Absolutely. So we find that the lumen maintenance factor, as you well know, is really the differentiator with some products. And we have light loss factors that we can assign for each of our products that showcase values after 50,000 hours of operation, or even in some cases 100,000 hours when fixtures are on for longer periods of time, like a parking garage. In interior spaces, we're typically looking at the 50K column and offering values there.
Yeah, and I think the other thing to take note of is certainly, and I think most of the audience know this, if you're going into a industrial space, take note of the ambient temperature, especially if it's unconditioned and
Absolutely.
where the luminaires are going to be exposed to high ambience. You need to make certain that that's captured and known. when trying to go through the selection process of the luminaire.
Absolutely.
All right, the other one I wanted to ask you about is from a control standpoint. So if somebody wants to add controls, maybe SmartCast, how does that influence the design process and what you do on the indoor space?
So we can show fixtures within a certain distance, so around windows where they would be uh, daylight harvesting or time things. We can turn fixtures off and see what the values would be, midday when we're getting contribution from windows. We're not going to show the windows, but we'll show the contribution from the remaining on fixtures. We can also show the different, we're going to give you a full bill of material of all of our Cree SmartCast or all of our products. We usually send the controls portion off to our controls experts. We have a couple in the group, but we also use Garrett, and he usually puts the bills of material together on some of our more popular accounts. So
Perfect. Hey, we got a question here, a good question. So
awesome.
how do we find our calculation results match with the real world? So are we pretty accurate when we do a lighting design in terms of what gets delivered?
We do. Actually, we've had several challenges, not recently, but we have had several challenges in the past. And whatever wizardry and magic the lighting analyst teams are doing, we have found, even in our own space, which was the example that we were looking at here, the values that we get in our office space with a calibrated meter are extremely accurate to our calculations in AGI 32.
And I think that's also shows the importance of the input, right? If the input's not
Absolutely.
accurate and there's
Yep.
some variables that are really critical that are not captured and the wrong assumptions are made, then kind of you start to move a little away from as accurate as maybe you would like to be.
That's a great point, Dwayne. And I mean, there will always be variables outside of our control. Maybe we got the wrong mounting height, or perhaps the wall texture and color is not quite accurate. We Once we get those variables in, like I said throughout my presentation, the better information we get on the front end, the better the outcome will be. And there's always going to be some unknowns, but we try to be pretty uh, conservative and make things a little bit more conservative than what they really are.
Yeah, I don't think the question came up in the outdoor space. It's also very interesting there where, things like trees and other obstructions that I'm guessing you typically don't model, can certainly
That's true.
influence the amount of light hitting the parking lot as well.
Well, the other concern there too is, I mean, yeah, you could put a tree in, and we've seen instances where people have taken measurements on day one, and then day 30, after everything was planted, those trees can flourish and grow and develop canopies and really affect the light values that you're seeing.
All right, so I think it's time for us to make like a tree and get out of it, as I would say, and Back to the Future.
That's right.
You want to advance to the next slide, Jim, and I'll wrap up shop.
Yes.
Great. I do want to thank Jim for his time and his presentation. I also want to thank the audience for joining us. I do want to announce that we are moving to a bi-weekly Friday cadence, and this is our schedule through Thanksgiving, then as we kind of start getting into holiday season. So next Friday, we'll have the human factors, the impact of better light on healthcare facilities. We did one around education facilities. We'll take a look at healthcare. And then we have a two-part series with John Vollers around Flickr that's coming up as well. So take note of that. As Jim mentioned, we are recording all the sessions. They are available on YouTube. So some of the sessions that have been referenced, if you want to go back and watch them, they're available there for you. And then recently we've added Spotify for your listening pleasure. So you can check us out there as well. With that, again, I want to thank everybody for your time and wish everybody a great weekend. Take care.